All right, guys. We're gonna be working with page 27 through 29 right now. Page 27 through 29. And again, we're still working with helping you with assignment numbers, I believe 6 and 7. Right now, I think 8 will be coming up because I think 8 is our law of sines, which I'll do in the next video. Here we go. So the key is how do you find reference angles? This is a quick review. So this is on page 27. Page 27. Page 27. So if you're going to find a reference angle in quadrant 1, it is just theta. It's just the angle itself. If you're going to find it in quadrant 2, it's 180 minus theta. If you're going to find it in quadrant 3, it's theta minus 180. And then if you're going to find it in quadrant 4, it's 360 minus theta. So it doesn't matter where it's at. If it's 205 degrees, what's the reference angle? Remember, we're finding reference angles. So we're finding reference angles. So if it's 205, this is 180 degrees. So in quadrant 1, quadrant 2, quadrant 3, quadrant 4, 180 degrees, it's past. So we're going to take theta, which is 205. 205 minus 180, that means my reference angle is 25 degrees. So if I drew a triangle, it'd be 25 degrees. Okay, so that's one way to look at reference angles. It's theta, 180 minus theta, theta minus 180, and 360 minus theta. You just got to decide what quadrant it's in for you to use it. And remember, your reference angles make a bow tie shape. So you've got a little bow tie shape here to them. So that's what your reference angles or your triangles are going to look like. All right, so let's see here. I went too far. So if we look at page 28, and we still stick with the theme, so we're going to move to page 28 right now. So page 28, we're going to add some info. So we know that this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. This is my x, this is my y. This is 180 degrees, or it's also the same as pi. So we've got these pieces. We know my reference angle in here is theta, so let's do reference is equal to theta. Reference is equal to 180 minus theta. My reference, can't spell it. Watch this. Reference is equal to theta minus 180. And then my reference is equal to 360 minus theta. And now my x and y are positive. Oops, this one's negative. My x and y, this one's always positive here. This one's always negative, positive. This is always negative, negative. And this one is always positive, negative. And this is my x and this is my y. This is my x and this is my y. Now, if we take that idea and we deal with the fact that we know on the unit circle that we have x is always related to cosine, and x is related to cosine, and x is related to cosine, we